Now we are nearing the completion of our market contract. I almost cannot believe this. It's like I actually thought it was going to be a lot much more than this, but it's crazy. Like, it's we managed to implement this in, not that much code anyway. But yeah, I mean, I guess I don't know. It's unbelievable. If I had written this code like maybe 2 years ago, it'd probably be 4 times as long. But wisdom comes in, wisdom, experience. Eventually, it comes in. So yeah, we want to repay a loan, right? So to repay the loan, you need to repay the amount that the person borrowed. Okay, so amount borrowed in stable. Um, so amount borrowed plus interest. Okay. Um, One thing that I think is worth noting is we currently are not handling interest like what the person should repay because we do not yet know how long they're borrowing it for. Okay. Um, Another thing is within our data types, we also need to store when a person borrowed the amount because we need to know like, okay, you borrowed now, you're repaying now, this is what the interest is. So we need to add a field here. Uint 256. I'm going to call this um, time of borrow. Okay, this is going to break a lot of things. Um, Here should break some things. Yeah, this should fail. Yeah, so time of borrow needs to be added. So let's do block dot timestamp. Okay, all right. It might also be worthwhile to emit time of borrow, but I mean, there's no need because on the subgraph, it tends every transaction has block dot timestamp, so we can always search for that. That's fine. Um, to repay a loan, we need some things. Calculate um, repayment due. Okay. Confirm that repayer is equal to borrower. So basically, only you can repay. No one's gonna repay for you. We're locking that down. Then update loan values, etc. Okay. All right. So this is kind of like how it's going to work, right? So we already know that we have an interest per second. We need to know what the principal, time, and all those things are. So we come back to our library, get repayment due, okay? And we say uint 256 amount in stable coin borrowed. I'm being very explicit here so that because when we say amount, sometimes it can be very confusing. Amount of what? Interest uint 256 interest rate. What else? Now that I think about it, we don't need to store the interest rate within the struct because it's a global variable, but we'll leave it there for now. It's no big deal. Amount in stablecoin borrowed, interest, uint 256 initial borrow time. Okay, external view returns. Okay, uint 256. This is standard PRT. There's no, principal times rate times time. So this is a pure function. Let's make it enter now. Sorry. our internal function is going to do return principal is okay. Before I do this, I need to do some refactoring. X and bring it in here. Okay, the market, what's it called? Market support library. So we're just going to say market support library dot this. Market support library dot this. Okay, good. That's all that. So I'm bringing this in because sometimes the asset decimal matters. Okay, format document. For simplicity, we're going to assume that like we're dealing with like only 18 decimals in terms of the assets that we are repaying. So the very first thing is we need to do amount in stablecoin borrowed multiplied by the interest rates. These values have to be divided by 118. Times, let's say, seconds passed. Typically, this should be in 40, to be honest, it's fine. I mean, for simplicity, I'll leave that in 256. But I want this value, yeah. Actually, scratch that. Let's do it this way. Per dollar UN 256 per dollar amount due is equal to interest rates per second interest rate per second multiplied by seconds passed. Okay, and we are then going to multiply this entire value. Let's look at the units. Interest rate per second it's kind of like a big number. Interest rate per second times seconds passed. If we divide it by 118, it's going to go to 0. So what we do is we need to handle that. I need to confirm something. Give me a second. Okay, my hunch was right. So the per second amount due is interest rate per second times is dollar interest rate per second times seconds passed. This gives you the per dollar amount due. And now we know that the UNT 256, the interest due will be amount in stablecoin borrowed multiplied by per dollar amount due. Now, because I'm multiplying these two, we divide it by 1E18. Now, the reason why I don't divide by 1E18 here is because these two numbers are small. So if you look at the interest rate per second, I showed you here, it's a small number. And if you look at the seconds passed, it's also going to be a small number. It's going to be something that looks like this. so it's not going to be up to 18. So by the time we multiply and multiply, we divide by 18, it kind of scales our number back down. Okay. This would be like our interest due. Then the principal will be return amount in stablecoin borrowed plus interest due. So this is actually simple interest. We didn't use the compound interest. I can write a compound interest function later on. That's the one that uses the Taylor series. Yeah, but just to get this cost down to like so we can meet our targets in our times. I don't want adding much more complexity. Okay, so yeah, this pretty much is everything. We are then going to call this get repayment due here. So let's go to repayment, calculate repayment due. So uint 256 repayment due is equal to get repayment due amount borrowed. Let's call amount borrowed, okay? And interest rate per second is and the seconds passed. Yeah, we need to get that. So before we do, let's get that uint 256 seconds passed is equal to block.timestamp minus loans loan ID. Obviously, we're going to run some checks. Loans to loan ID and loan params, I think. Let's check data types. Yeah, params. Okay. Params dot time of borrow. Okay. Okay, loan params time of borrow. Okay, seconds passed. So this is block.timestamp minus this seconds passed. Okay, so that this is seconds passed. Okay, done. Repayment due, seconds passed, repayment due is this. This is the amount plus interest. So what we're going to do is we're going to create a version of this function that is read. Kind of like doesn't really make sense, to be honest, because every single time you call it, it's going to keep growing, but write it anyway. Function estimate repayment due, and it takes in pretty much the same two things, and it's external view returns uint 256. And what it really does is this, okay? And then it returns repayment due, all right? So, and the repay loan, we just call this function, so let's make it public, all right? So we say uint 256 repayment due is equal to estimate repayment due, passing same things, loan ID and the amount borrowed. Okay. Now, obviously, before we call this, here are some of the things that we need to check. Okay, I think I'm going to do the checks last. Let's finish the logic. Repayment due. So for the repayment due, before we transfer the amount, we need to update some values. So we're going to do, hold on, I know what I just said. I know why I'm doing this way. So we're transferring repayment due to this contract. It says I didn't use the transfer properly. Let me confirm. We'll transfer its message or send down rewards. Okay. So it should be address to an amount. Huh? To an amount, okay. But yeah, we need to then update some stuff, right? So what are the things we need to update? We need to, first of all, we need to update the borrower's info. Okay, so we need to update borrower assets available and borrowed. So first of all, let's start with borrowed. Borrowed takes in message dot sender. Okay, I think because mapping is quite bad. Borrowed takes in, oh no, you can't access borrow directly. We have to access it via borrower info. So we come to borrower info. What's the matter? Okay. Borrower info message or sender. And we're accessing borrowed, okay? And borrowed has collateral taking asset. So we need to know what the collateral taking asset. So we need to get the collateral taking asset from the loan ID. So hold on. Borrowed is not collateral taking asset. Hold on. Oh yeah, so they borrowed against that value. So we need to repay this. All right, so let's get the collateral taking assets. How do you get the collateral taking assets? From the loan ID. The loan ID tells us that. So let's get the address of collateral loans, loan ID dot params again dot loan ID params dot collateral taking address. Okay, we put this in here, collateral, okay, and then they borrow that amount, so now we want to repay whatever, so we're gonna give them back. We're gonna give them back the amount that is due. So the question that I have right now that I need to ask myself is, when the person is repaying the loan, they are repaying it in stable coin. So this amount borrowed, which is amount in stable coin, do we store it anywhere associated with the borrower? We do not, do we? We do not. So this tells me that we need to, because here we have the amount borrowed, and this is what the borrower needs to repay. So, oh, I see. So we don't need to store the amount borrowed. We need to get the collateral units used and refund it. Good. Yeah, that makes sense. So we get the collateral. So we want to, added stuff to it. So we want to reduce this amount by borrowed against. Now you might say, oh yeah, borrowed against doesn't exist. Yeah, it doesn't, because we're going to get it right now. So borrowed against is loan dot params dot collateral units used, which I think we wrote something into. Yeah, we did. We wrote something into here. And we stored it here. So collateral units used, borrowed against. So we decrement borrowed, and then we increment assets available. So we come here and we say borrowed against. Good. So we reduce the borrowed, we increment borrowed against. Did I say that we'll store repayment count? I didn't store it. I think we should actually store it. UN 256 repayment count. So we are only dealing with full repayments, not partial repayments. I think I've talked about this before. So we're gonna say something like this borrower info message or sender dot repayment counts has been incremented. Borrower message sender dot active loan count, we decrement it because we incremented it previously here. Now let's look at any other field. The reason why we keep this is in the future, if you want to determine creditworthiness of a person, this could really go a long way. Okay, so active loan counts down, this up. Yeah, so this is all sorted. So this handles the repayment for the user, I think. Yeah, this is it. And we need to change the loan state as well. So we need to current status. So we need to do loan ID dot current status should be equal to loan state dot repaid. So the current status is no longer active, it's now repaid. Okay, but we're not going to delete any of this information. This information is going to still be like available, there's no need to, so it's fine. Okay, I mean, unless maybe I do some research and it reveals otherwise. So yeah, we've just managed to update the loan values, and now let's run our checks. All right, so let's confirm some things. First step, let's just call this run checks. First, we check that the caller is equal to the person, the right person. So let's say require require here that the loan to loan ID, actually, I move that up, params dot borrower is equal to message dot sender cannot repay this loan. Cannot repay this loan. Okay. All right. Then second thing is we need to confirm you are not authorized. You're not you're not the lender. You're not the borrower. Second thing is require that the loan is in an active state. So require that the loan current status is equal to loan state dot active. Loan only active loans can be repaid. Good. Yeah, these are the two most important things, I think. Yeah, then we check our validation for arguments. Require that loan ID is not equal to bytes 32 0. Okay. Invalid bytes ID. Okay. Require. Oh yeah, there's one more thing. We don't support partial repayment. We only support full repayment. So this is going to happen here. So we're going to require that the amount borrowed must be greater than or equal to amount borrowed. Here. So we come here. So we require that loan ID dot params dot amount borrowed so amounts borrowed that you're returning must be greater than the amount borrowed. So we're not going to say greater than or equal to, because we're not going to allow, actually, yeah, so we'll allow flash loans. Amounts repaid must be greater or equal to amount borrowed. Okay, good, done. We've run our checks. All right. The final thing is the repay loan. We need to emit an event. Now, this is very important for the reasons I've shown you before, the subgraph. We need to tell the subgraph that, oh, this is the loan ID, this is the amount borrowed, this is the amount repaid, this is who borrowed it, and this is the active loan counts. Like basically we need to create a robust event. All right. I think once we're done with the repay loan, the final function which I would write is liquidate loan, and then we'll write all our setup functions, and then we'll clean up the contract. And I think I'll run tests. Then once the tests are good, we move on to the next phase. Okay, but we are gonna finish writing the contract. All right. So that's why this session is long. Okay. So let's just quickly finish the event. Okay, so event is loan repaid. So there are some things that I'd like to see. One is bytes 32 loan ID. Okay, I need to see the amount repaid. UN 256. Repayment due. Okay. Sorry, loan ID, amount repaid. Okay, let's call it that. What else do I want to see? I want to see the person who is making the call. Now, I obviously don't need to emit this because I can get it on chain, because I can see like the message was sent out on chain. But sometimes it helps to have it, So I'm just gonna say uint address borrower. Okay, obviously this should be indexed. Borrower. Okay, I think if that's the case, I can move this here and I can index it as well. Okay, amount repaid. What other things do we want to note? We want to confirm the repayment status. Oh yeah, we need to add the loan status here as well. Okay, so it's very important when you are indexing your subgraph. Okay, so let's do loan states, loan status. Okay, we're gonna emit that as well. I also think we'd like to index it. Okay, so we put it here. It might not allow us index it, but we'll see. Amount repaid. I'd like to see the borrower's repayment count. I'd also like to see the active loan count. Okay. Amount repaid. Uint 256. Active loan count and Uint 256 current repayment count. This kind of gives us like an assessment of a user's creditworthiness. Okay, all right. Cancel. Didn't ask you for that. All right. Boom, 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 boom. Take this away. Let's go up here. Done. Okay. Apparently we can index the loan. Yeah, there's, like I said, there's one more thing I'd like to index here. After liquidation price, I want to add loan status as well. Very important. Okay. I mean, borrowed is borrowed, loan repaid is loan repaid, but I mean, you might as well do that. So borrow here. Let's do loans. Loan ID. Current status. Okay. Done. All right. So yeah. Oh dear. I made a. Let's come here. Repay loan. I'm going to leave this here so I can emit the right thing. Okay, and then I'll delete it. Emit loan repaid. Loan ID, obviously. Whoever is the borrower, message or sender. Loan state, obviously. Amount repaid. Repayment due. Active loan count. Repayment count. I should also point out that it might be worthwhile to add these two functions to what we're emitting here. So I'm going to edit this event borrowed again and add these two. Why? Because of our subgraph. Okay, I hope it's going to let me add it. All right, done. Okay. Active loan count. And repayment counts. This is going to matter when we're doing our subgraphs. You know, it's not going to matter now, but you see why. You know, yeah, this is done. Wow. So yeah, we also need to write a function that allows the borrower to withdraw some of their assets. Okay, because they might decide that they want to withdraw some of their assets after repaying. So we'll write the withdraw function, and then we'll also write the liquidate loan function, and then we'll be done.